Hello and welcome to the Omnex webinar, Safety Products and Electric and Autonomous Vehicle Standards. Today's presenter is Chad Keimel. Chad Keimel is the CTO and founder of Omnex. Chad has served on the Malcolm Baldrige Board of Examiners and received numerous quality achievement awards, including the Quality Professional of the Year Award from the American Society for Quality. Chad has been working in the automotive industry for over 30 years, and Omnex principals have been active on different automotive standards, including QS 9000, ISO TS 16949, Semiconductor Supplement, APQP, FMEA, and Core Tools. Chad conducted the first worldwide witness audit for QS 9000, a predecessor to IATF 16949. Chad has spent over 20 years in software development in various capacities. He assesses and works in automotive software for Agile, ASPICE, and functional safety. Chad is a certified lead auditor for IATF 16949, ISO 14001, ISO 9001, FSSC 22000, ISO 45001, AS 9100, ISO 1345, and several others. He is also an Intact certified assessor for ASPICE. During this webinar, if you have any questions for Chad, please enter them in your questions dialog box. Go ahead, Chad, you can take it away.
Thank you, Miles. Welcome, everyone. Let's spend the next hour talking about safety products, electric and autonomous vehicle standards. Really, this is the future of where the automotive industry is going. You know, when Miles reminded me in his intro into, what happened in 1995 when QS 9000 came, we recognized that, of course, we had been in business for almost 11 years or 12 years at that time, and we recognized what a key standard that was and how it was going to change the automotive industry globally. And really, it was a start for Omnex to go from a Michigan-based company to a global company. So what's happening here is as important in the sense that the whole product is changing from combustion engine to electric vehicle and then to autonomous vehicle. So let's look inside and try to understand what's going on in our own industry. By the way, just to tell you very quickly, we're founded in 1985, headquartered in Ann Arbor, Michigan. A couple of things we did that really made us who we are. We did a global rollout. We actually helped Ford Motor Company with the emerging market strategy. This global rollout was actually for QoS in 1993. All right, as Miles mentioned to you, we're on many different committees, both ISO committees and many different automotive companies, and we sort of pride ourselves, in being in all the key standards development that is happening in the automotive industry. So you can divide this presentation into two halves, and what I'll try to do is I'll try to talk to you about what is happening globally and what is forecasted to happen globally in product safety, in products that have safety in it, electric and autonomous vehicles, and then we'll touch on AV and EV basics so that we understand what this product, this autonomous vehicle and electric vehicle basics are, so you understand a little bit more why cybersecurity is very important, why functional safety is very important, why ASPICE or software becomes suddenly important. And then what we'll do is spend about half the webinar talking about the standards, what we call the 7 pillars of EV and AV at Omnex. All right, let's get started. So let's talk about the electric and autonomous car global movement. What is really kicking off things is that countries have announced that they're going to phase out of gasoline vehicles, or as we call internal combustion engines. So you'll see us in many places use the word ICE. So we're good. They're moving from ICE or ICE to electric vehicle and diesel. Electric vehicles really is what the countries are asking for. And this is what set things off, so much so why you'll see that in the news, GM has announced they're going all electric, and they're given a time scale, which I'll share with you. Volvo, Porsche, and Volkswagen, as soon as you see GM, one of the largest car makers, and Volkswagen, one of the largest car makers, talk about that the combustion engine is at its very end and they're going all electric, it sets everything else into motion. So here are the EV targets by OEMs. You can see from BMW to Volkswagen in the very bottom and Volvo what they're forecasting. So by 2030, the thought is that a significant part of the car market will be electric. Okay, let's move on. What has happened? What is happening currently as we speak? Something that's been going on for the last 10 years. And really, it is really the amount of safety that's come into the car. And, a part of that is this announcement between the 20 largest OEMs and the Department of Transportation. It is a commitment that by X number of years, 2022, that all the car makers will be putting in automatic emergency braking into the car. Okay, and but there's a lot of other technology that's coming in, which I'll share with you sort of midway into this presentation, not as coming as already come. And then, of course, much more is planned to come, which I'll talk to you about. And then, of course, in the end of this in this slide, you can see also the idea of backup cameras and the idea of the car stopping, so that it doesn't run into children or senior citizens. All right. So improving safety in transportation has led to a number of what they call mechatronic features in the car, which is the hardware and software. So which then leads to this slide that talks about the content of the car going from about 33% to about 50% of the car being hardware and software by 2030. Do you see this? You see how it has crept up on us. In fact, in the I was doing a lot of work in the semiconductor industry, and the semiconductor industry was slowly adding on more and more software. So much so, I thought the scope of at that time it was ISO TS 16949. I thought needed to say hardware and software. And then, of course, we all had to audit software as a product in the ISO TS 16949 audit at that time. And that's what's really happened in many of our organizations, and I have many good companies listening to my talk here today. In all your organizations, and all the organizations, we're doing quite a few ASPICE assessments, we're finding software is a little bit of a stepchild. It is outside the purview of your new product development process. Well, folks, hardware and software is here to stay, and the headcount is going to keep on increasing. So, I would imagine by 2030, half the organization will be hardware and software. I like this little comment here in the bottom by AAA that said, hey, you know what? It's getting so complicated. we can't fix these vehicles anymore. We just can tow them to the service station. All right. With hardware and software becoming larger and larger, and especially software, and I told you it is really very neglected. And you talk about distributed, development. We have hardware being developed in one part of the world, software being developed in one part of the world, the testing happening in a different part of the world. No wonder we're having so much software failures. And verbally, talking to the OEMs, some of them tell me up to 50% of the warranty today is really, when they look at the root cause, it goes to software. And so in terms of failures, what we're talking about is mechanical failures with pretty much single point failures. With the advent of hardware, suddenly you're going to be seeing what is called multi-point failures. I'll say hardware and software. Suddenly you're seeing that something that you may not see by itself, when you put it together with something else, and you'll start seeing multi-point failures are, if this happens and this happens, then it'll fail. Okay? And so that's why we have new tools coming into the automotive industry and hardware metrics to handle these multi-point failures that we didn't used to have as much of before. So what will happen? First, and you're already seeing electric vehicles in the market. You're going to see more and more of the electric vehicles in the market. And at some point, cars will go autonomous. Even if we go level 4 autonomous, I think it'll lead to what is called MAAS, or Mobility as a Service. I took this out of, so currently Omnex is presenting in a number of autonomous car conferences, and we're participating in it because, as I mentioned to you, we want to be in the leading edge of what the changes are, going to happen. And it's huge changes that are happening. So I took this out of one of the presentations. It's in a bibliography of my bigger paper. But so I don't quite, believe the amount of penetration is as much as they claim, as you can see here. But this idea of new vehicle sales, where they're saying about 33% or so is going to be on-demand service. On-demand service is using an Uber or a Lyft, where people will start owning cars. So the idea is, if you're able to call up a car and everything will happen automatically, service, and they'll dispatch a car without a driver that'll sit in your doorstep, and you might use that car for the next 2 hours, and then you'll give it back. Okay? So, what this presenter was trying to show is that the market capitalization, or the availability of capital, is going to shift slowly from the black, which is the car makers, to the mobility as a service provider. Okay, all right. So yes, indeed, this is going to happen, but the speed in which it happens depends on whether we can, I think, soon as you even go into level 4, and we'll talk about this because I'll talk to you about level 4, SAE level 4 in a second, you can start seeing things like this happening. All right. So there's a lot of change going on. Suddenly, to understand these two slides, which I'm not going to go into the detail, what I want to share with you is why it's happening. What do we know? We know hardware, sensors suddenly are very key, software is key, and Uber and Lyft and the new entrants like Apple and Google suddenly are entering in this market. And why? Well, let's just look at the 2 pages here, and you can see, and folks, I haven't even touched upon the 300 new startups in China. So indeed, what we like to say is this is another gold rush, right? The company that can reach level 4 or level 5, in fact, it might be some sort of a breakthrough that happens, and maybe one car company will have a monopoly of 6 months for 6 months or a year or 2 years, and if they do, they're going to walk away with the market. So it's very interesting to see what's going on and the alliances being formed. Why? Number one, it's going to cost a lot of money to go to level 4 and level 5. I don't have time to talk to you about the reasons why, but coming up with the amount of scenarios you have, and think I'm going to talk to you about something called SOTF, safety of the intended functions. And I'll tell you that's one of the reasons why companies have to spend a lot of money is because of these scenarios. And number two, it's going to take a consortium to come up with that money and to come up with the innovation that we all need. All right, lots of interesting things to think about. What are the implications of the shift to EV and AV? Many implications are for your product mix in all the companies that you are in. You need to be able to do hardware and software, and you absolutely have to make sure your product will still be there in an electric vehicle. What is the role of software and electronics? Well, it's got a role front and central. And companies, organizations, people need to know. Somebody like me, we need to know, Omnex needs to know how to work hardware and software, and that's why we're in the midst of this change. And luckily for us, we've had a software company since about 1998, and we have lots of experience in software and hardware. Remember, we helped write many of the semiconductor standards, and we have been working, with all the key electronic companies for all this time. But all of you need to be thinking the same. What are my competencies? What are the new competencies? What do I have? What is my, background and my competencies sufficient? How do I change? What will be the balance of power? How will things shift? They're already telling you the market capitalization is going to go from the manufacturer to the mass. So that's, need I say more? How about the supply chain? Folks, I haven't talked to you about the standards, but the standards require, we already knew in mechanical cars with some hardware, mechatronic systems, we needed to keep in concert. I mean, many of the problems were happening is we don't know how to do new product development with this distributed, design and suppliers globally. In fact, we helped this large electronics company, well-known icon, come up with the automotive platform, looking at all the places that needed to implement automotive standards just for this one platform. Think of it as a couple of different circuit boards and a bunch of semiconductors put together. They had 300 different sites involved. I kid you not. I can tell you this much. If you're going to have 300 sites involved with doing hardware and software and systems, so the supply chain is very key. We need to take a good look at our, when I say supply chain, I mean just in this case, the design, how just a design is being done. Forget hardware and manufacturing right now, just thinking design. So partnerships and agreements, why? I've already talked to you about that. So what we'll do now is, I think I've clearly discussed with you the implications of this EV and AV market. I'm going to pause for about 30 seconds and we'll spend the next 10 minutes talking about the EV and AV vehicle. And so we understand, what are the major parts of it before we look into the standards. Folks, I've been joined by Dr. Juan Pimentel. He is on the cybersecurity and sort of committees, and he has edited about 6 different books on safety for SAE. Is that right, Juan?
That's right.
Okay. All right. Let's continue with the EV and AV basics. Pretty much what we need to understand, and we're not talking hybrid here, folks. We're just talking about the electric vehicle. I just bought my first hybrid, and it's sort of brand new, and I'll use that as an example when I talk about SOTF. So what we have here is a high voltage battery, motor control unit, charger, electric motor and transaxle, AC, DC converter, electric power steering, and of course, what this brings in is lots of new technology, increased software and hardware, safety concerns in the electric vehicle, cybersecurity concerns. Well, the cybersecurity concerns come in soon as you offer internet in the car, soon as you connect through via phone, soon as you have, if you want to do any software updates to the vehicle. All of these suddenly bring in cybersecurity concerns, supply chain concerns, which I already mentioned to you. All of us leading to a number of functional safety issues, right? And these are some of the common functional safety issues from unintended acceleration. You understand that electric car can accelerate really rapidly. Electric shock. In fact, the voltage, as somebody, we have done a number of electric vehicles and a number of battery management systems here at Omnex. And as the American plant manager of a Chinese battery manufacturer mentioned to me, showing me his 5 or 6, prototype, batteries and battery management systems, he said, Chad, any one of these could take out a city block. Okay, so we have these vehicles with that kind of power running through, and so we have to be aware why functional safety is very important. Explosion, battery fire, brake failure, the battery fluid leak. Especially if there's an accident, there's a concern for those who come in and try to, help the people in the accident, in terms of the battery management system, and electrocution, and also harm from the battery acid.
Yeah, that's right. I mean, these electric vehicles brings a new host of failures, really, that it's totally related to the electrical nature of the vehicle. I would say that the most critical item, in fact, would be the battery. So that battery needs to be designed with the utmost care, using functional safety requirements, functional safety goals, so that we don't have any accidents related to the high voltage system that these batteries are all about.
Great. So let's continue. Next, what we'll do is we'll talk about, and folks, I had to be very economical here in what I add, only because it's an hour that we have. So let's quickly walk through, and have many, many key slides on the autonomous vehicle basics. Number one, we need to know that the self-driving vehicle has many different hardware and sensors, radars, cameras, lidars, night vision, ultrasound, dead reckoning sensors, all of this so that and you'll see here so that the car can go from level 1 automation to level 2, level 3, level 4, level 5. So here then, I've been referring to this SAE automation levels, and you'll see here, as Juan pointed out to me a few weeks ago, it doesn't say autonomous car. Very carefully, the SAE committee called it automation. But of course, if we said automation cars, you wouldn't understand. So we call them autonomous vehicles. So what does it mean? We'll just say this as no automation in 0 and full automation in 5. I think we understand the extremes. How do we understand in between it? So this is a good picture to keep in and keep in mind to understand the difference between level 1 to level 5. The first one is that picture of the steering wheel, right? That's the, at one end, the driver is steering. Soon as you hit partial automation and conditional automation, the car is doing self-steering, okay? Maybe at least even for a few functionalities. Then, of course, as it goes from, level 4 and level 5, it is really steering by itself. And then, who is seeing? Is it the driver or the vehicle? When you hit 3, the sensors and the cameras and the radars are good enough to manage by itself, but still, in the end of the day, when there's a contingency, which is plan B, the driver takes over, okay? And when you go to 4, you have the car doing all 3, and then level 5, all 3. So what's the difference between level 4 and level 5? And we'll just say, we'll use a term, it's the scope. It's the ODD. And ODD stands for?
Operational Design Domain.
Okay, it's the operational design domain. For example, right now, we're in Ann Arbor, Michigan. The University of Michigan has a vehicle picking up students and going on a route in North Campus. That's I have not driven it, but if it's completely automated, it's a level 4. Or we have heard that there are people who have a vehicle operating in a automated inside what do you call it? A shopping center. Okay, a mall is what I was looking for the word. So in a mall, and that's a level 4. And I believe in the near future, companies like General Motors with the Super Cruise may have, a fully autonomous vehicle in the highway. Right? Soon as you have that, you'll go level 4. And soon as GM is able to succeed in that, I think you'll start seeing things like the MAAS or the Mobility as a Service. Okay. Soon as you do that, you can have these cars on one end, have people use them during the highway and then take something like an Uber or a Lyft from the end drop-off point to their homes. You can start seeing that. And then, of course, level 5 is when truly you'll start seeing mobility as a service. Another way to look at this picture is to see the amount of hardware and software that is needed as time goes by. Of course, this is a slide looking at today's technology. I am certain there will be breakthroughs in the future, and maybe instead of 32 different sensors, cameras, radars, will go to much less in the future. Okay, and I think Juan, we were discussing LiDAR being the most expensive of that, and how Tesla doesn't use any LiDARs at all. Right?
That's right. The state of the art of LiDARs is probably the least advanced as compared to cameras and radars. And there is still a lot of room for development and innovation, like Chad just mentioned. And I believe that in the next 5 or 10 years, we're going to have completely new redesigns based on just these lidars. That
because it's very new. Lidars are very new. In fact,
in automotive it's new, but
yeah.
in other areas are not that new. But you're right, in automotive it's totally new.
Yeah, and folks, Juan is an expert. He's done a lot of work in hardware. And Juan, if you look at our 5-day certification course, we're coming up with a hardware, part 5, version of it. And the case study we're using is actually a LiDAR for functional safety. All right, folks, let's move on. And this is the last slide, and maybe I've lost a few minutes here from our standards discussion. This is sort of the trajectory. You can see in 2012, we had things like blind spot detection, lane change assist, forward collision alert, and so on. And I get a good chuckle out of it. So you can see here also level 2 in 2016. I don't see the automated parallel parking that I saw advertised a few years ago. In fact, I told you I just bought, I won't tell you which vehicle, top of the line vehicle in this car. And I looked for the parallel parking, automated parking. They said, they had it a couple of years ago. It never worked that well. And so this great car company,
Really?
a company, took it out of this most recent version of it. All right, and you can see here that the Lyfts and the Ubers and the Waymos are planning to come out, and the Apples are planned to come out sort of 2021. The advent of the disruptors. Level 4 is also being planned around that time frame, and then you can see commercializing of level 4 is in the 22-25 time frame, and level 5 autonomous 2030. I want to explain all the reasons why, but Dr. Koopman out of MIT likes to say that there are infinite scenarios that could happen, and he said it's going to take a long time before you see a level 5, but who knows? We'll wait and see. And the question is not that we have every scenario, meaning suddenly a child runs out, there's a person crossing the street wearing XYZ and the light changes. These are all different scenarios. Of course, we can't capture all of it, but as long as we capture enough of it where the fatality rate is as much or lower than a human driving, right? All right. With that said, let's talk about what this has led to, and this is the future of the automotive industry, what Omnex calls the 7 levers of the automotive industry. Starting with IATF 16949, that's not going away, along with the score tools, all the way to Agile APQP. Folks, in this presentation, we don't really talk about Agile APQP or the supply chain practices. It's not that we don't, in fact, we think it's very important. Agile at scale and the supply chain handling is very important. And but we'll talk about 4 out of the, we'll talk about 5 out of the 7 standards. Starting with IATF, all of you know the IATF. I'll just say this, with the advent of the new standards, IATF 16949 is going to have to change. How we manage suppliers needs to have to change. How we do change management needs to change. Traceability will change. Configuration management will come in, and so on and so on. And what else needs to change? The APQP and the PPAP processes will change. In fact, we are giving a number of presentations on this topic. Those of you interested in looking at where new product development is going with all these new standards, please email Miles, and we'll be happy to share that with you, including a white paper. So this APQP process fundamentally you can see here, we never thought about the system architecture of system, hardware, and software in phase 2. We are not aligning, we don't have requirements flow down. We don't have testing flows up, or the idea of the V. And I don't have time to talk about that in this presentation, but Omnex recommends satisfying the V using the linkage, of course, taking the requirements into a DFMEA, coming up with the test requirements, and doing the testing in a DVPNR. And of course, folks, the requirements have a decomposition, and so requirements flowing down and testing flowing up. Oh, I had make a couple of points here. That the idea of the architecture of system, hardware, and software, in systems engineering is a critical requirement of these new standards. All right, let's get down then to talking about these 4 of the new standards coming out. As I mentioned to you earlier, software and software failure is a big deal. So the industry is looking at Automotive SPICE, which is a framework for designing and assessing software development processes. And folks, I just did an assessment last week, and let me give you some thoughts here. I'm going to say this company had maybe 150 requirements for this very key feature that they're adding into the car, and it's going into some of the top name brands, one which has already got it, the other one which is going to start first quarter next year. They had to redo, half of the requirements, because when they went and looked at the alignment between stakeholder requirements and system requirements, they found it was inadequate. Number 2, when they went to the testing requirements, 46 out of the maybe 120 test cases had to get updated. So you understand then the implication, that's only one very small part of ASPICE, but the idea of the alignment, the review of the requirement, the review of the test cases, all of which are base practices, are part of the journey of trying to become, having better quality in software. So the whole idea of ASPICE is that it's going to help you design, better software that meets the system requirements. All right. And of course, it definitely will help the cooperation in this complex supply chain, because most of us have, software suppliers, many of them which are global in nature. Okay. So you can see here, these are the requirements. We say SIS1, SIS2, SIS3, SIS1 being the stakeholder requirements. So in dark blue are the system requirements and testing requirements. In lighter blue are the software requirements that have to link to the system requirements. It also forces the idea of architectural design. So in one of my assessments a few months ago, I saw the unit design was, all they had was system requirements, and they went to unit design from there. And what else is, they had number of different testing that they showed me, which of course was inadequate because they didn't have that level of requirements defined. So folks, there's a lot of work for us in new product development. When we put something like ASPICE in place, we need to have first, we need to have what the AIAG-VDA calls a structure, which is a system, hardware, and software, and then you have to have the flow down of the V, and then the flow up of the testing. All right, but here, so let me explain this picture. There are 26 processes in ASPICE, and 16 of them on what is called a HIS scope. So typical OEMs are asking for the HIS scope and at least a level 2. Everybody would like to see level 3, but at least a level 2. So level 1, level 0 is nothing. Level 1 guarantees those base practices. So there are something like 6 to 9 to 10 base practices for each of the processes, which you have to implement, and assessors come and assess. And then as soon as you put down performance management and work product management, you work to a level 2. Level 3 is when you have a standard deployment that will be tailored for every project in the company. You're a level 3. Okay, so up to a level 3 is what we have to strive for in the automotive industry. But right now, start with a level 1, move to a level 2 after that. So that's ASPICE. What else do we have? The standard functional safety 26262 that came out in 2011. Omnex has been working with the standard since about 2009, and we did a whole e-car in 2009, and we've been doing a number of different projects in 26262 since then. What is 26262? Well, they opened the scope of 26262 in 2018 to include buses and motorcycles, and they took the weight limit out of the automobile, but the scope is still E&E, okay? Electronics and electrical, and it's looking at safety. It's scoped down to safety, and the whole idea is with the increase in technological complexity, the software content and the mechatronic implementation, there's an increase in systematic and random failures. So this is something E&E focus 26262 focuses on, and is looking at addresses hazards caused by malfunctioning behavior. I will talk to you about SOTIF soon, but just understand it. You do a HARA, hazard analysis, risk analysis, and you understand the hazards. Out of that, you identify the ASIL levels and the safety goal and the safety requirements, and then it goes on. Otherwise, pretty soon I'll tell you the whole standard with the functional safety concept and the technical safety concept. All right, so it is 26262 is really part 2 and part 8 aligned with IATF 16949. Part 2 is a general, it says general requirements, but the general requirements are things like competency management that goes with IATF. There's audits. Audits are called confirmation measures, okay? And it also brings in the safety case and so on. Very important requirements in part 2. Part 8 has a support processes, and the supplier management is called DIA, or distributed interface agreements, okay? And so on. So part 2 and part 8 align with IATF 16949, and then you have a concept phase where you identify the ASILs and the safety goals and the safety requirements. From there, you have to identify the technical safety concept of the system in part 4, hardware in part 5, and software in part 6. And of course, ASILs can be decomposed. Pretty much you don't like ASIL Ds because ASIL D has such a high requirement in terms of hardware metrics. Oftentimes we have to do, what is it called? I'm not
ASIL decomposition.
Yeah, but you'll have to end up doubling your design. That's not the right word to use, but there's a cost because you'll have to put a redundant system. That's the word I was looking for. To get the ASIL D requirement, so frequently you do decomposition, at least to ASIL C, that we can do with less expensive parts. Of course, if you have no ASIL, it's cheaper versus ASIL C, okay? All right, so 26262, very important. And as we mentioned to you, there's a part 11 with semiconductor guidelines, hence our new class for semiconductor industry with the LiDAR example. Okay. Next, we have SOTIF. SOTIF deals with functional insufficiencies. Let me give you a good example in my new car.
Okay.
Yesterday, I put my key in my briefcase, and it's got a kick sensor, and I did a kick sensor, and the trunk opened up. Okay, so I put my briefcase in, I closed it, I couldn't open the door. And then I come back and use the kick sensor will not open. It did not sense that the key is inside the trunk. It's a functional insufficiency. I'll just tell you, my Cadillac, which I drove, and I replaced with this new car, this flagship of this new company, not new company, a great company, but the kick sensor designer had not designed that. And I panicked because I didn't know how to get into my car. And I actually called the dealership, and luckily I found a person who told me, hey, I couldn't figure out anyway, long story short, I got it opened, but you can see the kick sensor designer had not thought of this scenario. But this is a good example that it's not just for the autonomous car. You have to think sort of for every little design, including a kick sensor design. And, there's not only functional insufficiencies, but it could also be misuse, somebody trying to misuse. So you got to think of all that using sort of. And so there's the idea of a scenario. A scenario is a set of actions. In my scenario, the trigger, so let's look at this. So every scenario starts with the initial scene. In my scenario, the trigger event was really, I put the key in my briefcase, and then I put that into the trunk, okay? And it was not a safety event, but you can understand it could have been, if it was a safety functionality, it could have been a safety event. Here's an example. When operating on a highway, a vehicle's automated emergency braking, the AEB system, misidentifies a road sign, thinking it's a stop sign, and it brakes all of a sudden with the greatest emergency. Of course, what is the safety issue here? Not only to the driver, where maybe the airbag goes off, but also could be a rear collision. Okay, so you understand what sort of is. All right. Next, we have 21434, the one that Juan is on. But Juan, you're also on the sort of committee, if I'm not mistaken.
Right.
Yeah. And so right now we have the J3061. There's a guidance standard, but we have folks at Omnex already started using 21434 integrated with J0361. Okay. And what is this idea of cybersecurity? Anytime we're connected and, there's a problem. So here it is, network data services, call centers. My car, if I touch a button, I talk to somebody, Map provider. Yep, I have that too. Of course, well, that's not smart city. In fact, Juan is going somewhere to give a talk on the smart city, where everything talks to everything else. So that's got cybersecurity issues. GPS, V2V, there's a standard for communicating between vehicles, and of course that has opportunities to get broken into. Cellular, smartphone, internet, cloud, all of these has this idea of a threat landscape where there are organized, well-financed attackers. It could be like that in some parts of the world, who are trying to just cause disruption. As you all know, I don't know what they'll do. They'll hold your car as hostage and tell you maybe they'll say, give me $2,000 or $1,000.
That's possible. Yes.
Individual hacker just getting in, amateur, insiders. Of course, there could be insiders who designed the car that have got a back door. So all kinds of threat characteristics that could be there that we need to design for. Folks, I'm going to go by this. We did this specifically for one customer. Let me just go on. So we have the 21434, and I will say, Juan, is we know it's a work in process. As I mentioned to you, I like the first picture better than the second picture, but you have general consideration. Clause 4 is like clause 2
That's
in
right. Yeah.
functional safety, and then you have the concept phase, very similar to the concept phase in functional safety. The risk assessment methods, there's one additional, what is it, a vulnerability assessment that needs to be done other than the TARA?
No, they have actually more. I mean,
Yeah.
the whole thing of risk assessment methods,
Yes.
they list many methods, but this is supporting methods, basically. It's not really part
But
of
I
it.
think if you do two, if you do the TARA and the vulnerability assessment, that would pretty much be.
Yeah, TARA is key. If you do
Yeah.
the TARA, then that gets you, a long ways, but that's not the whole thing.
Not the whole thing. Yeah. And then, of course, well, I said concept phase earlier. We have the concept phase in clause 8.
8, yes.
We have the product development. This product development has system, hardware, and software, which was clearer in the old picture. And of course, you have validation and verification, as you have to be, because you have the V model also in use here. And of course, very importantly, as Juan will tell you, the singular most biggest difference is that you have to continue protecting yourself, and you'll have to get OTA or updates to your
That's right.
software.
That's right.
Yeah, go ahead and explain
And
that one.
this is the reason why, in this case, there are several clauses, 10, 11, 13, 12, 13, which means that in the post-development phases, you're not done with cybersecurity because you need to consider additional vulnerabilities that come into place all the time. So that never stops. So that's the major difference between cybersecurity and safety. In safety, once you develop the vehicle, basically the post-development is fixed. Here it's totally dynamic. So it's an ongoing thing that you still need to consider and worry about.
Folks, Juan also has written all our cybersecurity courses, and he'll also be teaching them. And thank you, Juan. All right, so here is sort of the functional safety and the idea of the TARA going into the cybersecurity concept. And of course, at the end of the day, everything comes down to system requirements, hardware requirements, well, system requirements going into just like the functional safety requirements, overall requirements, along with the functional safety requirements, there'll be cybersecurity requirements, and both of them go into the system requirements. And then system requirements have to get decomposed into hardware requirements, and from the HIS, and then also to the software requirements. And there you go. So what do we know? Juan expects 21434 to be completed, as I have read from other members of the committee, by the end of next year. And tailoring is allowed in the cybersecurity activities, meaning that you can tailor it to meet your project. If a rationale is available, then you can not do something, but you have to offer the rationale why
Correct.
you have excluded something.
Correct. Yeah.
Otherwise, they're mandatory. All right, folks, that is what we wanted to share with you in terms of the EV and AV product safety. Number one, if you've got products, safety products, if you're designing for the electric vehicle or the autonomous vehicle market, these are the 7 different standards and levers that you need to apply. And we covered 5 of them in this presentation. We have not talked about Agile or not really talked to you about the supply chain activities. But let's finish up here with our summary and conclusions. So folks, the point to be made is that there's a product change from gas, ICE, or the internal combustion engine, and diesel vehicles to EV and AV in cars, trucks, buses, and in countries like China and India, with a big two-wheeler market, also in the two-wheeler market. And many of it is getting mandated by governments and adopted by car companies. This product change will cause a number of changes in how we design products, how we manufacture products, and also the competencies of people in the organization. The OEMs and tier ones need to develop strategies on coping with this change. This product shift and level 4 and level 5 automation will give rise to the mobility as a service market. So our thoughts are, first, everybody will shift to EV while they simultaneously work on the autonomous vehicle, and at some time, the EV and the AV will merge. I hope that all makes sense. There are 7 levers, as you see here, and we talked about 5 of them. And all of us in the automotive industry will need to adapt and change our systems to these new standards. The EV and AV companies need to adopt systems engineering, updated APQP, FMEA and DVPNR linkage, functional safety, SOTF, and cybersecurity. The software, so what we also mentioned in here, is a need of a software tool. Folks, this is one of the things Omnex is working on, a software tool that manages requirements, allows you to do the requirements decomposition, updating automatically the DFMEA, linking to the DVPNR to give you the V model and the testing going up, but also integrating in functional safety with APQP. And then when the standard comes out next year, our goal is to have cybersecurity also integrated in. Folks, it is almost impossible to design products and manufacture products with these standards that require us, our design houses, and our manufacturing and our suppliers all to work in concert in lockstep. We also believe OEMs and suppliers need to adopt a design and process reuse strategy. You can do a reuse strategy of functional safety and cybersecurity. Talk to us, we'll explain to you how that's done. That's the only way to really save money. Juan, did you want to add any words to this?
Well, more than words, I think I'd like to ask you a question.
Okay, I'll just do that. Let's do this. Let me finish up. Thank you. We'll take your question as a first question. I just want to tell you a little bit. We have our IATF 16949 series. Auths are different courses because, as you know, we're known to be very automotive. Here's our automotive spice. What we haven't added in here is our INTAX. We're offering an INTAX is the VDA is governing the A-Spice. And if you want to be a certified assessor, you have to take an INTAX course. And we're offering our first course in November. And we have a SOTF course, Agile series, 26262 series. See this, writing effective requirements, test cases, hardware and software, for 26262. We also have that for Automotive Spice. And FMEA, FTA, along with how does FMEA, FTA, and FMEA integrate and link together. And then, of course, a Cybersecurity Series that you helped write. And some general classes from a systems engineering and a basic classes as an introduction to engineers for autonomous and electric vehicles. Okay. And of course, the supply chain practices. And we have software. We have AIAG-VDA FMEA software and 4th edition software that helps you do the V model, and software that integrates in functional safety and APQP and cybersecurity. With that, let me move on to questions. Let me have maybe Miles, you can print out the questions that we have, and I'll take Juan's question as a first question. Go ahead, Juan.
Yeah, one of the main problems that organizations will have in the future will be integrating all of these tools and all of these levers. How do you envision solving that problem?
Yeah. So I'll tell you what companies are doing. Large OEMs, and I want you to, are creating, of course, they have the product design group. They're creating a parallel cybersecurity group. They're creating a parallel functional safety group. And the functional safety people are doing the functional safety. The cybersecurity people are doing the cybersecurity. So what would we say at Omnex? We would say fundamentally that is not the way to satisfy these standards. Yes, there is a special, there is a role for these folks who specialize in it, but we need to have it integrated in the competencies of the engineers working there. So one of the things, Juan, as a CTO for Omnex, I get to write down implementation methods working with all of you. And one of the things I said is, we don't want anybody, when we do our implementation, we're not looking for any increased headcount. Of course, we need a couple of people with at least 50% time free to work with us to implement these standards, but the whole goal is to integrate it into the existing new product development process, both in methodology and then truly there's got to be software.
Yeah, that makes a lot of sense.
Yeah. If they don't have software as a tool that integrates it, I don't know how they're going to do it if they don't have that. So those are the things as part of my job as R&D for Omnex. This is what I'm focusing on, and we have software products coming and we have methodologies coming. Let me go to the next question. Hang on, folks. Sorry, the second question we have, what is a key standard? You mentioned many standards. What is a key standard we have to implement? And a little bit, I have bad news. You have to implement all of them. And I do see now, because functional safety has been here, for a while, pretty much everybody is got religion over 26262. But Juan, I have no clue what people are doing for cybersecurity. And part of it is, I guess 21434 needs to come out. But there's a great need for cybersecurity because everything is so connected today. People are not doing anything with SOTIF. And of course, ASPICE is happening very fast. Some of the OEMs, US OEMs, German OEMs have been doing this for a long time. US OEMs and truck OEMs are making it a requirement. So ASPICE is happening very fast. So you got to implement all of these, folks. All right, we'll take another question. What is a takeaway if I'm following regional government policies? Why do I need these EV policies and launch as governed by our nation's government? I don't fully understand it, but yes, there's a relationship to what governments are asking and what companies are doing. It's very clear that, the strategies of our largest OEMs, I showed you that list, is going to I would not worry unless you're in the OEM, I would not worry about the policies. Now that we know which way the OEMs are going, we just need to worry about ourselves if we are in the automotive supply chain. If you are part of the OEM strategy setting, yes, some of the things President Trump said would trouble me. Some of the threats he has made to car companies following the California mandate, all of them signed on to it. Several large OEMs signed on to it, without being asked, to say that's the way we're going to go. But actually, our president announced punitive action against those car companies. So I would really watch those closely if I was the OEM. But it's in the supply base, it is very clear, that which way our OEMs are going. Let me go on I'll take on two more questions and we will finish this webinar. How do you see APQP changing? let me mention to you, I'm busily writing a paper about new product development along with Juan actually, and configuration management, requirements flow down, traceability. Let me see that I wrote down the V model, and I'm missing several things, but all these are going to impinge the new product development process along with different new tools I have to do. I have to do a TARA for cybersecurity. I have to do a HARA for functional safety. I have to do a FMEA and a FTA for functional safety. I'll have to do the same, I'm sure, for cybersecurity. And so suddenly, these are all the changes, and these are fundamental and large changes, as big as the advent of APQP in 1995. Okay, let's take our last question. Is ASPICE only for software? So ASPICE, if you looked at that, there are 16 processes. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 processes. If you get that slide, I can tell you exactly. There are 10 processes which are hardware, system and software related. So the software processes, so everything is, starts from system. In fact, in the HIS scope, 4 of them are system related, 6 of them are software related, okay? And so, yes, how we do the system design is also impacted by the base practices of level 1, level 2, and level 3 of ASPICE. Folks, thank you very much. We apologize for going a little over the 1 hour allocated. I hope you enjoyed this webinar. I surely enjoyed talking to all of you. We are going to continue this discussion of EV and AV launch with a series of webinars on it. You can expect us to talk about new product development probably next, then functional safety, cybersecurity, and ASPICE as we continue this series and as we move forward. Thank you very much for attending the webinar. Hope to see you. If you have a need for implementation, please do give us a call. Please do attend our training, and please do come to our future webinars. Thank you all very much. Take care now. Bye-bye, everyone.